All right. Also, from our trimester one review packet right here, this is number 17. It's another counting principles idea. The question states three girls and four boys are seated randomly on a straight bench. Find the probability that the girls sit together and the boys sit together. Okay. Well, this is going to be counting principles, but we have to think for just a second. So I'm going to draw our scenario. We've got three boys, three girls, four boys. All right. So we have seven benches. In order for all of the boys to sit together, then and all the girls to sit together, for that situation to happen, we would have to have boy, 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 and then girl, girl, girl. So that's one way that we could make this happen. So there's one possibility. The other possibility, because they both have to all be sitting together, and if I split them in any way, we don't have that anymore. So the other situation where that could happen would be boy, 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 would be that way. So the two scenarios that we have, it's either that one or that one. So we know that there's two different ways in which this could possibly happen. Okay? So now the deal is we have to figure out what is the probability, how many different ways could I organize four boys in the first four seats? Well, hopefully we recognize that this is just 4 factorial. 4 factorial tells us the number of different possible combinations we could have. Where if we were organizing this, so boy 1 could be in the first seat, in the first opportunity, then boy 2, then boy 3, then boy 4. But we could also organize it where it was boy 2 is first, and then boy 1. And so 4 factorial tells us how we could do that. Similarly, to organize the girls, this would be 3 factorial. And obviously, hopefully you see that it's the same on the other side. So if there's two different ways of doing this, then our function, or the ways that we could organize this, is 2 times 4 factorial times 3 factorial. Or I could write this, these are the number of possible different ways that this could happen. Which would be 2 times 4 times 3 times 2 times 1 times 3 times 2 times 1. Got all of that. And then find the probability that the girls sit together and boys sit together. So now we just have to figure out over the total probability of this happening. Well, if there's 7 people all together, then the probability, or the number of ways that we could combine these ideas, um, so possible combinations, well, if there's 7 people, then it's 7 factorial. So what we need to do is we need to divide, and I guess let me write this out. I know it's getting confusing, and I apologize. So this is 2 times 4 factorial times 3 factorial all over that 7 factorial. And I am going to write it out just so that we can cancel where I can. So let me write this as divided by 7 times 6 times 5 times 4 times 3 times 2 times 1. All right, so now we just need to cancel. And that's why this, I guess, is a paper 1 question, because, I mean, we could do this on our calculator fairly easy. But if we write it out in expanded factorial notation, it's not that horrible. So that 2 cancels, the 1's cancel, obviously. 3 cancels, got a 4 that can cancel. 3 times 2 is 6. And I can't go any further. So this would give me 2 over 35. Right, I haven't lost anything. So my answer should be that there's a 2 over 35. Uh, that's the chances that that happens. We don't have a calculator on this, but let's just, if we can see what 2 divided by 35 is. So about a 5 or 6% chance of that happening. Right. I think that's manageable, and I think that makes sense. I hope it's helpful. Have a good one.